Long back, sometime in the 1800s, it was thought that electricity and magnetism are two completely different topics, that there was no link in between them. But during that time, there was a scientist known as Hans Christian Oersted. Now, Hans Christian Oersted, a Danish chemist and physicist, was responsible for finding this missing link in between electricity and magnetism. So, how did he find it? So one day, Hans Christian Oersted was lecturing his physics class on electricity. Now he noticed that the circuit which he was using to demonstrate electricity exhibited a peculiar behavior. The moment current was flowing through the circuit, there was a slight deflection in a compass needle that was placed on his desk. But the moment Christian Oersted switched the circuit off, or in other words, stopped the supply of current to the circuit, he found that the deflection no longer existed in the compass needle. Now he was intrigued. Hans Christian Oersted knew that the deflection in a compass needle can only be caused by a magnet because the compass needle itself is a magnetic substance. So he studied further on what exactly was happening. And then he found out that electricity and magnetism are related. Whenever there is a flow of electricity, there will be presence of magnetism. So this was a groundbreaking discovery in that time. And it was because of this discovery that it paved the way for many more discoveries in the future years to come. So he was responsible for finding out the missing link between electricity and magnetism. So now let us see how electricity influences a magnetic needle. In this video, we are going to find that when current flows through a conductor, it is able to influence a magnetic needle, and in what way. So notice this video. Now current is not flowing, but as soon as current starts flowing, you will find that there is a deflection in the needle. And the direction of deflection of the needle changes if I keep the wire differently, which means that the direction of current changes, and depending on the direction of current, the direction of deflection of the needle also changes. So now let us see a simple animation to find out in what way or what is the pattern of the magnetic field around a current carrying conductor. The apparatus we have considered is very simple. We have taken a battery, a cardboard with a hole in it, a copper wire that is properly insulated. This will be carrying current, and a switch. Now you will notice that some iron filings are poured on top of the cardboard, and through the hole of the cardboard, the copper wire is passing. Both ends of the copper wire are connected to the battery which you have taken. Now initially, as you can see, the switch is open and no current is flowing. So the iron filings are randomly placed around the copper wire. Even if you tap the cardboard at this point, you will find that the iron filings still remain randomly placed. Now let's see what happens when the switch is closed and current is allowed to flow. The moment the switch is closed, current starts flowing, and you will find that these iron filings arrange themselves in a certain pattern around the copper wire. This is because current is flowing around the copper wire and causing the generation of a certain magnetic field. Now the pattern of the magnetic field or the magnetic field lines can be easily determined from the pattern of the iron filings. If you look closely, you will see that the iron filings have arranged themselves in concentric circles around the copper wire. Now the direction of magnetic field lines can be easily plotted with the help of a compass needle. Now when a compass needle is placed at different points, it will be deflected. So due to this deflection, the red part of the needle will be pointing in different directions, and it is in this way we will be able to find out and map the direction in which the field lines are pointing, and thereby also decide how the magnetic field is oriented around the conductor. So now you might be wondering that it is very inconvenient to find out the pattern of magnetic field lines with the help of such an elaborate experiment. Now there is a simpler way by which we can find out the direction of magnetic field. Now if we hold the current carrying conductor in this way and hold it in the manner as you can see in the picture, such that the direction of current is given by our thumb, then the direction in which the other fingers will be curling the conductor will give us the direction of the magnetic field. And we have found out from the experiment that the magnetic field is in circles around the conductor. So over here, the direction of magnetic field can be easily determined by the right hand thumb rule. Now while you're holding the conductor, make sure to be careful because current will be flowing through the conductor while you determine the direction of magnetic field. So what does the right hand thumb rule state? The right hand thumb rule states that if we hold the current carrying conductor in the right hand, so let's say that this is a current carrying conductor and we have held it in the right hand such that the thumb points in the direction of current. So let's say current is flowing from bottom to top. So the thumb is pointing in the direction of the current. Then the fingers will encircle the wire in the direction of the magnetic field lines. So this means, as you can see, my fingers are encircling the current carrying conductor, and this will be the direction of the magnetic field lines. So let's say current was flowing from top to bottom. So in that case, I need to hold it like this, and the direction of magnetic field lines will be as given by the curl of my fingers. Now you will notice that the right hand thumb rule is so because if you hold it in the left hand and do the same, the direction given by the curl of your fingers will be opposite, and that will be wrong. So this is why the rule is known as the right hand thumb rule, and that is very important to remember when applying it.